So let's consider the case of nonmetals down to nonmetals. Now, unlike the metals bound to nonmetals case, we're not going to worry about the charges on the atoms to tell us the relative ratios. So when we look at naming nonmetals bound to nonmetals, what we're looking for is a naming system that actually tells us the number of atoms and vice versa. We're going to use the chemical formula to figure out the number of atoms. This will set the prefixes on their names. And when we go from the formula back, when we go from the name back to the formula, we're going to use the prefix to tell us the numbers in the formula. So let's look at two examples of the formulas to names. We have CF4 and N2O4. Now, in all cases, we're going to give the second atom an IDE ending. The IDE is to tell us that this is the more electronegative element. It takes a negative charge. So in CF4, you're going to start by writing out the names of each element. So we've got carbon, and we've got fluorine. But again, fluorine's going to take the negative charge, so it's going to end up being fluoride. Now, because carbon doesn't have a subscript in front of it, we're going to leave off any type of prefix. If you don't have a prefix, this means that you only got one of that type of atom. But we've got 4 fluorine atoms, so this is going to tell us that it's tetra fluoride. N2O4, we have nitrogen, and we've got oxygen, but oxygen's on the right side again, so this tells us this is going to be an IDE ending, negative ion, so this is going to be oxide. Now in this case, we have a 2 on the nitrogen, so we need a di to specify our 2. When it comes to the oxygen, we've got 4, so once again we're going to do tetra. And again, the tetra comes from the 4 on the oxygen. So dinitrogen tetraoxide. We reverse the naming. Again, all we're going to do is read off the chemical formula. So if we have dinitrogen tetraoxide, we know we have nitrogen, because nitrogen's in the name. And we know we've got oxygen because we got that oxide. Now we're going to use the prefixes to tell us how many each of the atoms we have. So for the di, we've got 2. And for the tetra, we now have 4. So N2O4. For carbon tetrafluoride, we're going to start by writing the name. Carbon. Fluoride tells us we have a fluorine. We don't have a prefix in front of the carbon. This tells us we only have 1, and we don't have to worry about putting that in the chemical formula. Tetrafluoride, the tetra, tells us now that we have 4.